Hi, everybody. Welcome. So this is our first walk into a virtual lab. So you've probably seen me before, Dr. Nanette K. Hartley. I'm the physical sciences coordinator, and I'm going to be walking you through the virtual labs that we're going to do. We have some information that we wanted to pass on to you about how these things work, where you can find them, exactly what to expect from them. And unfortunately, we do have a couple of pain points, some things that don't always go the way you would expect. And so I like to give my students some information about those things and how you can navigate your way through them and what you want to watch out for. I also like to give some introduction about what these labs are about because we don't necessarily talk about the labs that much in the lecture. We don't have a lot of time to do so. So I wanted to make sure that we had time to make that happen. So that's what these videos are for. Okay, so I'm going to be doing that. Now, in order for me to do that, I need to share my screen. So that's the first thing I'm going to do. And where I'm taking you at this point is to show you one of the shells. Now, this is the shell for one of the courses that's set up for fall of 2025. This probably is not your shell because this class probably isn't going to run, but this may or may not look exactly like your shell. Okay, there will be several components that will be in the same place. Not all of them will be. Right. When you want to get to D2L, all right, or into ALEKS from D2L, that's what I meant, ALEKS from D2L. Instead of going into course content, what you're going to be looking for is the opt-in for ALEKS access. And you'll see the ALEKS version 1.3 link that's here. If you click into that, you'll see an ALEKS link. Now, once you've done your sign up for this, you'll be able to click this to get into ALEKS. Unfortunately, I can't do that because that takes me to an error screen because I get into ALEKS in a different way. I'm going to go back to that in a little bit, but I want to show you some information about this lab before we do that. But that's how you'll get there, is to go into your shell and then go into your ALEKS link. Now, I put an ALEKS link for my students on the front page. There's one that's down here, there's one right there, and I usually put one off on the side too. So there are several ways that my students getting into that. Your instructor may have given you other ways to get into it as well. But you need to make sure that you get into ALEKS because that's where your virtual labs are going to be. Okay, and the post-lab quizzes for those. So that's how we do that. So that's the first part. I'm going to minimize this so that we can talk about some other things. And we're going to do I need to go back. Okay, so here is our information about this particular experiment. I'm sorry, I'm a little clumsy today. So this is the information about this ideal gas laws constant. Now, this is the first virtual lab that you guys are doing. So I'm going to have a little bit more information when we get into ALEKS. But I wanted to talk about this particular lab first and why we're doing it and what it's about. Okay, so we've been talking about the ideal gas laws and what they're about. But one of the things that comes up for students is, okay, we've got this constant that goes with this, and it's got this little tiny value. How did we determine what that was? Well, it turns out that we found that there is this relationship between the pressure and the volume and the number of moles and the temperature. And those always work together in the same way, but only if there's this little tiny fudge factor. Okay, and that little tiny fudge factor is what you're going to be solving for today. So let's talk about how that works. Now, the objective of this experiment is to understand how a fundamental physical constant, R, can be experimentally determined. So we're going to figure out what that value is. The reaction that we're going to be studying occurs between magnesium and hydrochloric acid. So it's going to be magnesium, Mg solid, plus 2HCl coming to give me MgCl2 and H2. Okay, so that's the reaction that we're going to be looking at to make this occur. So next slide that we're going to look at. All right. The ideal gas law incorporates the pressure, temperature, volume, and number of moles into one equation. PV equals nRT. So pressure, volume, the number of moles, and temperature, T. where R is the ideal gas constant. Now, again, pressure has to be in atmospheres, volume in liters, N number of moles, and T in Kelvin. The total pressure of a mixture of gases is the sum of the individual partial pressures. Okay, so that is something that we have to be able to talk about. So if I'm looking at a total pressure, like in the barometric pressure that we normally measure, that's the sum of all the things that are in the atmosphere. Okay, so normally we're looking at like H2O and N2 and CO2 and O2 and all of the things that are around us. Okay, I may not know exactly what all of those things are. I don't remember, but it's the total of all of those things. Okay, so we need, and we can solve for each of them. We can do that. And if we know each of them, we can get the total. Okay, so that's useful for us. Now, our experimental procedure, we will measure the pressure, temperature, and volume of the collected gas. Okay, now that's the hydrogen gas. And a convenient way for us to collect that gas produced by a chemical reaction is to collect them over water. That's a way that we can make sure that the only thing that we've got in there is the hydrogen gas. Okay, whenever gases are collected over water, they do contain some water vapor. There's no way we can get around that. And that total pressure that's in that container is going to be the sum of the water vapor from the water, okay, and the experimental temperature, and the pressure of the gas formed in the reaction. So it's going to contain both of those things. And to determine the actual pressure of the gas, we have to subtract the vapor pressure of the water from the total pressure. So we've got to do a correction to take that water vapor out to make sure that we're measuring the pressure of that gas. Okay, so we have to do a correction for that. Okay, so that's that part. We will determine the number of moles of gas from the mass of magnesium that was used to react complete with the hydrochloric acid using stoichiometry. From this information, you'll calculate the value of the ideal gas constant. So what we're doing here, we talked about limiting reagent, right? And so the limiting reagent is the one that we have less of. And so that can be used to help us determine what happens. Because all of that is going to get used up, right? So the way that we can do this in the laboratory is to force one of those things to be the limiting reagent. And we do that by adding a ton of something else to make sure that all of this one thing gets used up. So if we make the amount of magnesium really small and the amount of HCl really large, then we know all of the magnesium is going to get used up. Okay, so that becomes our limiting reagent. That determines how much H2 we're going to make, and therefore we can figure out how much H2 we should be forming. Okay, so we've forced that into the position of being our limiting reagent. All right. So that's everything I wanted to talk about in terms of our background and procedure for the experiment itself. Now, the other thing we need to do is go in and start talking about ALEKS. So this is how I get in there. Remember, you will follow the link from D2L. And I have to get through a little bit of a different structure. Couple of shelves in here. So this is the one that I've set up for us to work with. Now, I have my assignments. And this set of assignments should look exactly like yours. And down here, we've got the virtual labs and the post labs. Okay. Virtual labs are in here, and I have the gas laws, ideal gas laws constant. So I can click into this. Oh, yeah, that's right. I wasn't looking at it as a student, so sorry. Let me go to the student view. So I can enter the student view. Now I'm looking at it like I was a student. Sorry, not like a teacher. And now I go back to my assignment list. Oh, that's right. I was going to talk to you a little bit about how ALEKS looks. So you should have been familiar with how we get to some things in ALEKS. We always go to our assignment list, and from our assignment list, we should be able to see all of our homeworks in the exam one. There's a practice test for exam one. That's helpful to get you, set up for those tests. We've got the exam two practice. That's helpful to get you set up for those tests. And then we've got all of the homeworks that are associated with those. We have our virtual labs and our post-lab quizzes. So we have things that go with those experiments, right? Now, we can come in here and click the gas laws, ideal gas laws constant, and that will take you to this screen right here. And you can start this. And this will take you to the first page of this experiment. You'll get some key concepts. You'll always get this when you start a lab, an overview of the experiment, how the lab will be scored, and some information about it before you begin. Now, all of this information is sort of important to you. You should definitely read it. What I tell my students is go ahead and make a screenshot of this. Why do I do this? Because it's my opinion that students should be able to use their notes when they take those quizzes. So what I do, and what I have done when I do this myself, and what I ask my students to do, is to make a set of notes. Trying to find, oh, okay. And so I make myself a set of notes that I've screenshots and things that I printed from the labs. So this is the introduction, all of the information from there that I have screenshotted. This is for a different lab that I've screenshotted, okay? These are some of the information that I was given. I'll show you where I got that from. And then I have some more information that they gave me to work with, more information that they gave me to work with, and then my report from my experiment. So I'll show you how to get to all of that stuff. But that is stuff that I encourage my students to either print out or screenshot and keep so that they have a copy of it, so that way when they're taking the quiz, they know exactly what to do. Because you often go through calculations when you're doing these labs and you probably have no idea how to do them again. That's bad, because if you don't know how to repeat them, you won't be able to do them on the quiz. So we need to know how to do those things. Okay. Now, if you scroll all the way down in the before you begin, it talks about how we collect the gases and the fact that there's water vapor pressure in here, and we have to use the eudiometer, I think is how that's pronounced. Don't quote me on that. And so that contains the water vapor pressure too, and so we have to do a correction for that. And they show you the water vapor pressure table. And so this shows you at any given temperature the pressure in millimeters of mercury that the water vapor has. Okay, so we can look in this table to find out what that pressure is so that we can correct for that pressure. This is very useful to us. So that's our introduction. Now, once we've looked at all of this wonderful stuff, we can continue to the laboratory simulation. What I'm going to warn you about is that every time you do one of these labs, there's going to be questions first. So you're going to have to answer these questions. Now, I'm going to pause right here because I'm not going to tell you what the answer to this is. I'm going to solve this so that I can move on, but I'm going to pause while I do it so that you can do this on your own. So now I'm in the next part. And what I'm going to do from here is I'm going to do this lab on my own. I'm going to stop every time I run into something that doesn't work the way I think it should and talk to you about that. Okay. Anytime I think it works the way, I run into something that seems weird to me that I think I should talk to you about. All right. This won't happen all that often, so you'll see a bunch of breaks in this. There is an AI summary that you guys will get access to so that you can see where the important parts are. It will give you the timing so you can skip to it so you don't have to sit through the whole thing. Okay, but that's how I'm going to handle this. Is I will do this lab, the first run that they ask you to do, and you guys will get to be able to see that. but I'm going to pause so that you have to do most of this on your own, and I'll just run through this for myself, and I'll be right back. Okay? So this is the first place that I was like, uh-oh, crap. I don't know where I can get to a periodic table from here. And I know that Alex is really picky about the values that we use in the periodic table. So I don't know what to do because like I don't see where I can pull up the periodic table, right? So that becomes a problem for me. So it's like, oh crap, what value does he want me to use? Well, this is the water pressure table. And then it says how to calculate ideal gas constant. So I'm going to click on this because I don't know what this says. And it's got a whole bunch of information in this. One of the things I see as I'm glancing down this is the molecular weight of magnesium. So this is where I can pull some of that information from. So now that I've found it, I can use it. So don't forget to look at your resources, okay? These little tags down here have very useful information in them. And these are things that I screenshot when I make those notes so that I know how to walk through these calculations. You'll notice that they give you a set of data right here. It's not the data that you will collect, but it's similar to it. What I recommend is that you take these numbers, then write in, like you can print this, write in your numbers right next to it, and then go substitute them out so that you can walk through the calculations. That's what I do. Okay. So I'm going to go ahead and pause here, go back to my calculations and what I'm doing, and we'll get back to things in a little bit. And this is where I got stuck again. So I got to this place, and I'm actually right here. So I'm supposed to use the thermometer to measure the temperature of the water. And I went, okay, I need to go pick this up, but I can't pick it up. So I went to show labels because I thought that this was the thermometer. I thought it was a mercury thermometer and I was supposed to use that. That doesn't say thermometer. That says uniometer. This is the thermometer. Oh, my bad. So I'm supposed to pick this up instead. So if you get to a place where you're stuck and you don't know what to do, use that show labels. It can help you find what it is you're supposed to pick up. So just a heads up on that. And here I am with a problem. So I did all of these things. I zoomed in on the barometric to measure the barometric pressure. So I zoomed in and I saw this and I went, okay, that's 779, right? So I typed that in and now it's right, which means I did something wrong. And what it said was, did you report your number to the correct number of significant digits? That information is really useful to me because what that indicates is that it doesn't like how I reported this. And why doesn't it like that? Because this is exactly 779. So because it's 779, I know it's exactly on that line. It's not to the, to one side of it, it's not lower than that, it's not higher than that. I should be reporting this as, it's not gonna let me do that. See, and now I've got it where it is. So I need to reset this phase. And that's because I tried to go forward and it wouldn't let me do that. So I need to reset the whole phase. But I need to report it to one additional decimal place. So when you run into things like that where it says, that's not the right number of sig figs, that's because you haven't reported it to the right number of significant figures. So read the error message that you're getting. If it says to verify your calculations, make sure you check your calculations. If it says that's not the right number of sig figs, added another one, subtract one out. You should be using the rules that exist to determine that. Okay, so the numbers that you're using should tell you that. So if the mass that you used had two significant digits in it, which it does, 1, 2, that 0.020 has two sig figs. So the 0.0, neither one of those zeros is significant, but the 2 and the 0 at the end, those are significant. So that's why my moles of magnesium has 8 and 2. Those are significant digits. Okay, so those are things that I have to report. So make sure that you're consistent with your sig figs because it's going to complain about them. Okay. So now I'm here. And it says at reactions completion, equalize the liquid heights. Zoom in on UDometer, and use up down arrow to raise or lower. Okay, so I zoom in and I see that this is my meniscus. So I'm going to raise it because it says to raise it. And now I see that there's a liquid line right here, and I need to make this equal to this. Okay, so I go up, and I know I need to keep going. So maybe there, maybe there, maybe there. So I'm going to try this. And if I look at this, now the question becomes, what does that actually read? Well, that's an interesting question because the way that I look at this, I'm looking at this saying, okay, well, it's like right here, right? So that's 20.05, the way that I look at that. So I'll go to my lab data and I'll say 20.05 because that's what I think it is. And then I'm going to go on. Now, let's see if that works. So I'm going to do a whole bunch of other stuff. I'm going to see if that works. I won't know until I've done all of these calculations if that works or not, because then it will complain at the end if it doesn't like that number. So if it doesn't like that number, then I'm going to be in trouble. But because what will happen is this will turn red and all of these numbers down here are going to turn red because if this is wrong, the volume of the gas is going to be wrong. So this will be wrong, this will be wrong, and then this will be wrong. So we've got to make sure that if all of those things are wrong, it's because of this. And the only way that you can change this is to reset this phase. Okay, so that's where we're at. So that's the number that we're recording for now. And again, the way that I did that was to raise this so that the meniscus and the line are even. And I'm doing the best I can to read where that is. It's very difficult to do because it's hard to tell where the meniscus actually is, where that line actually is, because the way that they've done this with the shadowing makes it very hard to see. Okay, so we'll see how that goes. So here I am at the end, and I put in a bunch of numbers, and obviously it didn't like a couple of them. It says verify your measurement, lower the eudometer so that the meniscus is at the level of water in the beaker. Verify your calculation. Is your setup in your setup? Do your units cancel? And did you report your data to the correct number of significant figures? So I've got a couple of places that I need to look at this. One is, do I have the right number of sig figs? Is my measurement right? Probably isn't. And did I do my calculation correctly? So I need to go and look at all of that and see what's going on. Okay, so I'm going to go play with some things and see what I can do. And probably what I need to do is to change that measurement. Now, if I get out of this and I try this again, I know that doesn't work. Maybe, no, that doesn't work either. So again, I'm looking at this and I'm going, okay, well, I thought it was 20.05. Maybe it's 21. So let's see if we can go 21.0. No, 21.00. No, it doesn't like that. 21.05. And what am I doing here? I'm literally trying to guess as to what it thinks that number is. Is that reasonable? Eh. I don't feel that that is reasonable. I don't feel good about this. But again, it's a limitation of what we can see in this virtual environment. Right? I will tell you that the virtual environment is much, much easier than actually physically doing this because it's a horrendous process to get all of this physically set up. But there is a limitation in how you can see this. Okay, so I keep guessing until I get to a place where it works. So I just keep, okay, let me try this number, let me try this number, let me try this number. And that's how I have to go about this until it finally stops being red and it's happening. Not a great way to approach this, but that's what I had to do. I don't like it. It makes me very frustrated. But once I figured out that that's what I was going to have to do, at least I had some way to resolve it. Now, as long as I haven't clicked over this and I just put all my numbers in, do all the calculations, put all my numbers in, then I can still go and do this. Okay, so put all your numbers in, and then you can still adjust. So I've now made this thing happy, and I've done everything that it expected me to do. And after a little guessing, I finally got it. So you then need to submit this. And again, I would print that report. You can go back and look at it if you need to. You can go back to the report, print this, either physically print it or virtually print it so that you can take it into that quiz. All right. So that's everything you need to do. And if you need to go back and look at the whole thing, you can go back to the introduction. You can go back into the laboratory simulation. It doesn't matter what you need to do at this point. Okay. So there you have that. Don't forget to take the post lab, do the quiz. And after you do the quiz, there is a survey for this. So everything has a survey. We do want to know how you feel about these surveys because this is the first time we're doing these videos. So I want to see if these videos are helping. And if they don't help, tell me why they don't. I'm not going to be offended by it. And I won't do that. I won't listen to this until after the class is over. So again, please do everything you need to do and get this worked out. So don't forget that there's a quiz throughout this, and you'll need to pass that to. Actually, you won't need to be able to pass that to do this. We don't do a pre-lab per se, but so this is just for your information at this point. We're probably going to put a pre-lab quiz into this, but not right now. Okay, thanks guys. I'll stop sharing and I will end this meeting.